Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss another problem. So let me give you the problem first, then we will discuss the solution together. So our problem is an airplane travels 209 kilometers on a straight course, making an angle of 22.5 degrees east of due north. Then problem goes like this: how far north and how far east did the plane travel from its starting point. So this is our today's problem. Before discussing the solution, let me check the problem first. An airplane travels 209 kilometers on a straight course, making an angle of 22.5 degrees east of due north. How far north and how far east did the plane travel from its starting point? So as you can see, the problem is based on a displacement. The displacement occurs in the airplane. The magnitude of the displacement is given 209 kilometers and its direction is specified by this angle 22.5 degrees east of due north. We are asked to find the distance traveled by the airplane along north and east directions separately from its starting point. So we will use the idea of vectors. So what we do, let the positive x direction be the east and positive y direction be the north, right? We take the positive x direction as east direction, and the positive y direction is then the north direction. Let us draw the figure. So this is my x direction, positive x direction. This is my positive y direction. So this positive x direction is my east direction. This is my east, and positive y direction is my north. Positive x direction we take east, positive y direction we take north, as we have written here. Y direction is north and x direction is east. Then let me name it figure 1. Let this origin O be the starting point. So this origin O is my starting point for the airplane. So let the origin O be the starting point of the airplane, right? Then next thing is we have to specify the displacement. So let d vector be the displacement made by the airplane. So if d is the displacement made by the airplane, then we can draw it in the figure 1. So its length, that means magnitude of this displacement is 209 kilometers, as is given in the problem, 209 kilometers, and it is directed 22.5 degree east of due north. That means it's like this. Let me use some other color. So my displacement vector d is like this. This is my displacement vector d, and this angle is 22.5 degrees, because it is said that its magnitude, this length is, as we said it earlier, length of d is 209 kilometers. So it is 209 kilometer, right? It is said that displacement is taking place 22.5 degree east of due north. Since this is due north, It is 22.5 degree towards east from north, right? That is the meaning of 22.5 degree east of due north. That means from north it is towards east by an angle of 22.5 degrees. So let this angle be phi. Now we are asked to find how much plane goes along east and how much it goes along north. What we can do, we can resolve this vector d along east and north directions. So this is my dx, x component of displacement d, and this length is my dy, y component of vector d. So dx is what? It is x component of d that will give me how much the plane travels along east. So as you can see, dx is simply d cosine phi, right? D cosine phi, substitute the values. D is 209 kilometers. Then cosine of phi, phi is simply, this overall angle is 90 degrees. So it is 90 degree minus 22.5 degrees, which is 67.5 degrees. 90 degree minus 22.5, which is 67.5, right? So let us put the value for phi, cos of 67.5 degrees. So when you put the numbers, it turns out to be 80 kilometer. So this is my dx, 80 t cos phi, 209 km times cosine of 67.5. When you solve it, it is 80 kilometers. Then we find dy, which is d sine phi, which is 209 kilometer times sine of 67.5 degrees. When you solve it, it turns out to be 193 kilometers. 209 kilometer times sine of 67.5 degrees, which is 193 kilometer. So as always, check the calculation, at home. So we have obtained our answers. Dx is 80 kilometer. So it is the distance traveled by the plane along east. Is the distance traveled by the plane along east from its starting point, right? And dy is the distance traveled by the plane along north from its starting point, along north from its starting point. So this is how we use vectors in solving problems like this problem, right? There is one remark. Let me write that remark in red. We have used Cartesian components in this problem. As you can see, we represented the displacement by vector d, then we found its Cartesian components. We used Cartesian coordinate system, represented one direction as east, second one as north. Then we resolved the vector. Dx and dy are Cartesian components of d, and we solved it for our distances. So we have used the Cartesian components in this problem, even though this is important, even though the Earth's surface is curved. I write it in uppercase, is curved, and therefore non-Cartesian. We are using Cartesian components even though the Earth's surface is curved. That means Earth's surface is non-Cartesian. Then, for example, a plane starting on the equator and flying northeast will eventually be due north of its starting point, which could never occur in a flat coordinate system, right? Then how our solution, what is the justification for our solution? Justification is we can use Cartesian components, Cartesian coordinate system for such problems when the distances in our calculation are small with respect to the radius of the Earth. I repeat, if we restrict our calculations to distances that are small, with respect to the radius of the Earth, which is 6,370 kilometers. We can safely use Cartesian coordinates for analyzing displacements on the Earth's surface. As you can see, our displacements are small, 93 kilometer or 209 kilometer or 80 kilometer. These values are small compared to the radius of Earth, 6,370 kilometers. So non-Cartesian nature of Earth's surface will not affect our calculations much, right? So we can safely use Cartesian coordinates in such situations, even though Earth's surface is curved and non-Cartesian. This was a little remark. This may come to your mind. So our solution is justified. I hope you are enjoying these problems and making a notebook of it. So continue to enjoy the solutions of such problems. It's interesting. So this is all for today. Don't forget to like, share, and subscribe my channel. You can give a comment in the comment box. Thank you. God bless you. Assalamu alaikum.